So that then means water molecules, which you can see here, there's several of them, are able to be held together by weak hydrogen bonds, but collectively they're very strong. Think about the amount of energy that it takes to change water from a liquid to a vapor state, the amount of energy it takes to boil water, basically. For water to boil and for water to escape from the liquid phase into the vapor phase, it takes a large amount of energy for that to occur. And you're not breaking apart water molecules, meaning you're not tearing the hydrogens from the oxygens. What you're doing is, as the water in the pot is being heated and it's increasing in temperature, the molecules start vibrating more and more and more, and they eventually vibrate so much that the hydrogen bonds between water molecules break and the water molecules escape as vapor. And then if you have a cool surface that they condense on, then you get the water formed as liquid or droplets again. So in this picture, we see multiple water molecules, each water molecule being held together by hydrogen bonds, with the maximum number of hydrogen bonds that can be formed between each water molecule is 4. And that only occurs when water molecules slow down so much that you can basically form these 4 hydrogen bonds, and that occurs when water freezes. Now, water is a good solvent, and the reason why it's a good solvent is because the majority of substances in cells have some form of charge associated with them, as we can see here with our familiar sodium chloride or table salt. You can see the sodium ion is surrounded by the red spheres of the water, so those represent the oxygen atoms, and the oxygen atoms, remember, are partial negative charge. So we dissolve salt in water by, in essence, disrupting the ionic bond between the sodium ion and the chloride ion. And this is showing you a picture representation of how that happens. When you put salt in water, the water molecules form spheres of hydration, basically each water molecule separating each ion from the other, with the oxygens of the water molecules surrounding the positive sodium and the hydrogens of the water molecules surrounding the negative chloride. So in essence, hydrogen bonds are being formed that allow these spheres of hydration to occur that separate sodium from chloride, and it dissolves. Now, if you would take salt water and evaporate the water, you'd be left with salt or sodium chloride, because imagine in this picture all those water molecules evaporating, going up into the atmosphere. So now the sodium and the chloride ions would not be separated by spheres of hydration. They would actually be able to come together and ionic bond again. Another property of water is it forms a large amount of surface tension between a water-air interface that enables it to allow organisms such as this wasp to travel on the surface. It also enables water to travel up the xylem, which is the vascular tissue of plants. Here's a view of another property of water, and over to the right we see the water molecules in a rigid crystalline lattice where each water molecule is forming 4 hydrogen bonds. This forms ice, and ice forms an insulating layer in aquatic environments because ice floats. And the reason ice floats is not because air is being trapped between the water molecules. It's because as the water molecules slow down, they can form their maximum number of hydrogen bonds, which are 4. They're equally spaced apart, as you can see in this picture, and that makes ice less dense than water, which causes it to float. This is a very, very amazing characteristic of water. Most substances, as their temperature cools, they become more dense, not less dense. And in fact, with water, as it cools, it does become less dense, or excuse me, more dense, up to it achieving its most dense nature at 4 degrees Celsius. So imagine you have a pond and the air is cooling, so the temperature of the water in the pond is cooling. As the temperature of the water in the pond cools, you have slower and slower and slower molecular motions of the water molecules. So they're becoming more water molecules per unit volume. They are becoming more and more and more dense. So the water starts to sink. So the warmer water rises to the air, which can become cooled. The cooler water sinks to the bottom of the pond so it can be warmed. So you basically get a circulation effect, which helps prevent bodies of water from becoming too cool too fast. But eventually it is possible that in a body of water, ice will reach 0 degrees Celsius and freeze. And when this happens, instead of the molecules becoming closer and closer together like they had been, they actually space themselves apart because they form 4 hydrogen bonds. And when they form those 4 hydrogen bonds, that's when the water becomes its least dense and it will float, and that prevents water underneath that ice from cooling further. Another characteristic in living organisms that deals directly with a specific atom is pH. And pH stands for the power of hydrogen ion. And in essence, it is a measure of the amount of hydrogen ions in a solution. So if we look at the top near gastric fluid, that's the fluid in your stomach, we have a pH of 1. And if you look at those red dots on the line to the left, you can see they're more numerous at 1 than they are at 2, than they are at 3, and so forth as you move all the way down to 13 and 14. They are the least numerous at the higher pH values. Those red dots represent hydrogen ions. So the more hydrogen ions that are in solution, the lower the pH number and the more acidic the solution. The lower the number of hydrogen ions in solution, the less the hydrogen ion concentration, the higher the pH value, and the more basic the solution. And if you notice around a pH of 7, there's about an even number of hydrogen ions in solution. So that's considered to be a pH of neutral. So just to summarize or recap the chapter, there's a lot of different players in the chemistry of life, from atoms and their subatomic particles, protons, electrons, and neutrons, to the elements that are made up of set types of atoms. For example, the element carbon is made up of all carbon atoms. The element hydrogen is made up of all hydrogen atoms. To ions, which are atoms that carry a charge after an electron has either been gained or lost. To molecules, which are where 2 or more atoms join together to form a compound. And they can be joined by either polar covalent bond, nonpolar covalent bond, hydrogen bonds, or ionic bonds. All the way up to where we come up with what are called hydrophobic and hydrophilic substances. For example, we discussed water, and water is polar and can dissolve other polar substances. Those other polar substances are considered to be hydrophilic, whereas the ones that cannot dissolve, which we have not discussed, we'll look at those in the next chapter, are considered to be hydrophobic. That's like oil and water don't mix because oil is hydrophobic. We also discussed acids and bases, and an acid containing a large amount of hydrogen ions, whereas a base contains a small amount of hydrogen ions. Salts, such as sodium chloride, which can be dissolved in water through hydrogen bond forming, and solvents, which are the substance that is doing the dissolving. So for example, if you take salt water and dissolve, or excuse me, if you take salt and dissolve it in water, the salt is what's called a solute. It is being dissolved, and the water is called the solvent. It is doing the dissolving. One thing we didn't really discuss are isotopes. And isotopes, in essence, are atoms that are of a specific element type, but they do differ in their number of uncharged subatomic particle called a neutron. And these can be used in healthcare industry to track or trace where an element is going inside of a cell or inside of an organ or an organ system. And the reason why is because they're typically not stable. And because they are not stable, they emit energy. And this energy can be seen in the medical devices that we have. So I hope that this presentation has been helpful. This concludes Chapter 2 for Week 2. And